What's happening, people? Pastic here, and welcome back for another video connecting the original function to the derivative and focusing on the tangent line approximation of the original function. In this example, we're looking at a table of values below that represents values on the graph of the derivative h prime of x of the polynomial function h of x. So this is the derivative of a polynomial. The zeros indicated in the table are the only zeros of the graph h prime of x. And we want to use the table to answer the questions below. So let's do it. It says, on what interval is the function h of x increasing and decreasing? Give reasons for your answers. So previously what we did was we took the derivative of the function and we set it equal to 0 to find the zeros. Here you're looking at a table and we can see the zeros. It says that these are the only zeros of the graph, which is very important to know. So I see a 0 here. And I see a 0 here. How do I know those are zeros? Because the y value is 0. So other than that, we're going to use those as our boundaries. So we know there's a 0 at -2. We know there's a 0 at 7. We want to know where is the original function increasing and decreasing. Well, it's going to be increasing wherever the derivative is positive and decreasing wherever the derivative is negative. So I can see locations where this is happening. I'm going to go ahead and answer this question. You do the same and we'll be back up in a moment. Alright, so I've written my answer to this question. H of x is increasing on -infinity to -2. So h of x is increasing anywhere to the left of -2, because anywhere to the left of -2, h prime of x is positive. H of x is decreasing between -2 and 7, in here, and after 7, anywhere to the right of 7. So h of x is decreasing on -2 to 7, union 7 to infinity, because h prime of x is less than 0 on those intervals. Okay, so the next one says, at what x values does the graph of h of x have a relative maximum? In order for the original function to have a relative maximum, we need to see the derivative go from positive to negative. Because if the derivative goes from positive to negative, the original function goes from increasing to decreasing. So I notice that from here to here, at -2, the derivative on the left is positive, the derivative on the right is negative, therefore it went from positive to negative at -2, and I shall answer the question. So my answer reads, h of x has a relative maximum at x equals -2, because at this value, h prime of x switches from positive to negative. And again, that means the original function goes from increasing to decreasing, which is the definition of a relative maximum. So on to the next one. The next one reads, at what x values does the graph of h of x have a relative minimum? Justify your answer. So same idea, looking at our chart, we're looking for a relative minimum, which means the derivative goes from negative to positive, which means the original function goes from decreasing to increasing. Well, we already determined that there was a relative maximum here at -2. It went from positive to negative. So what happens at the next 0? It goes from negative to negative. That means on both sides of x equals 7, the graph is decreasing, which means there is no place in the graph anywhere where the derivative goes from negative to positive. It goes from negative to negative here at 7, which means it's decreasing on both sides. So that means there is no relative minimum. And we shall use the lack of evidence as evidence. Haha. Be right back. So I've written my answer. Hello. H of x has no relative minimum because h prime of x does not change from negative to positive. Okay. On to the next one. It says, if h of 3 equals 2, what is the equation of the tangent line to the graph of h of x at x equals 3? Then it says, what is the equation of the normal line to the graph of h of x at x equals 3? So in order to find the tangent line, we'll start there. We're going to need the point of tangency and the value of the derivative at that point. So let's find that, and then I'm going to write my equation, and we'll come back together. So what I've done here is I found the point of tangency. They tell us h of 3 equals 2. That tells us that the point of tangency is 3, 2. Then I look over for h prime of 3. Over here on the chart, h prime of 3 is -3. That's going to be the slope of the tangent line. So then I use the point slope formula to find my equation for my tangent line. Now I'm going to do the same thing for the normal line, Really, there's only one change for the normal line, and they'll just stay with you on this. For the normal line, one thing you gotta do different is take the negative reciprocal of the slope of the tangent line. So the normal line will read y minus 2 equals negative reciprocal of negative 3 would be 1/3 x minus 3. And there you have both the tangent line equation and the normal line equation. Isn't that precious? On to the last one. It says find the tangent line approximation of 3.1. So the first thing to notice is the value that they're asking you to approximate is 3.1. 3.1 is extremely close to 3. So we need to use a tangent line to the original graph at the x value of 3. And we've done that. This was the x value of 3 right here. This is the equation for the tangent line we're going to use to approximate 3.1. If this value was 3.5, then this equation doesn't really work so well because 3.5 is not that close to 3. It's close enough, but 3.1 is much closer. We feel a lot more confident about our approximation due to the proximity of 3.1 and 3. So I'm going to plug in 3.1 into this tangent line equation here for x, and we're going to figure out what our y value is, and I will be right back. So I've taken the value that they want us to approximate, which is 3.1. I've plugged it into the tangent line equation that came from the point of tangency of x equals 3 for the x coordinate. Those two values, 3 and 3.1, must be very close together or else this is not a good idea to do this way. So we used our tangent line from the previous example, plugged in 3.1, did a little bit of math, and we got that y was approximately 1.7, so h of 3.1 is approximately 1.7. One more time, the key when you're approximating using the tangent line, the number in question, the number that they want you to approximate, must be close to the tangent line equation point of tangency. If it's not close to the point of tangency, then you're using the wrong tangent line. That's all I got for y'all this time. Hope you learned something. Take it easy, everybody.